Continuing with our parallelogram in 7.3, today 7.3b, we're going to figure out parallelograms if we are just given coordinates. I say here there are 4 coordinates and we want to prove it's a parallelogram. So there are several options. There are 3 options. First option, choice 1, we want to use the distance and to show that the opposite sides are congruent. Okay, so let's first graph this. We have A is 6.2, B is 17.5. 17.5 is pretty. All of these are positive numbers, so I'm going to use my XY here. My XY axis are going to be along this side right here. Here's my X. Here's my X, my Y. So A is 6.2, so go over 6. 1, 2, 3, 4, 5, 6, up 2. So this will be A. B is 17.5, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, up 5, 1, 2, 3, 4, 5. So this will be B. Let me try to connect A and B. A to B, like so. C is 13.12. So this is 17, 16, 15, 14, 13. Go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will be C. Let's graph D. D is 2, 9. So 1, 2, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So this would be D. Let's connect all the remaining points here and here and here, like so. So here. So number 2, what general shape you form? Well, this is a quadrilateral for sure. We can definitely say that because it has 4 sides. So then when we want to use choice 1, we need to use the distance formula to determine that the lengths are congruent. So first, we want to find the length of AB. We got to find the distance formula. A is 6.2 and B is 17.5. Remember, it is the difference of x's squared plus the difference of y squared, all underneath the square root sign. So here, our x's are 6 minus 17 squared. Our y's are 2 and 5. 2 minus 5 squared. This also equals, simplify that some more, 6 minus 17. That gives me negative 11 squared plus what, negative 3 squared, which also simplifies to make 121 plus 9, which is the square root of 130, or something close to 11.4. BC, same formula. BC, now we have 17 and 13 for the x's, so 17 minus 13 squared. Y's are 5 and 12, 5 minus 12 squared. Simplify that some more. 17, this is 4. 17 minus 13 is 4. 5 minus 12 is negative 7 squared. This then 4 squared is 16 plus 7 squared is 49, which is then the square root of 65, which gives me ultimately around 8.1. Let's do the length of CD. CD here, And I'm going to underline this just to know these are the numbers I'm working with in a different color. CD is the number C, 13 and 2. So we have 13 minus 2 squared and 12 and 9. 12 minus 9 squared gives me 13 minus 2. This is 11 squared. 12 minus 9 is 7 squared. No, not 7. 3 squared. This is 121 plus 9 gives me the square root of 130, which is also 11.4. Notice that we have matching pairs. And notice that AB and CD are opposite sides. So far, this is a yes. Let's do the last one, D to A. A is, our x's are 6 and 2, so 6 minus 2 squared. And 2 and 9, so 2 minus 9 squared. That gives me 4 squared plus negative 7 squared, which is also 16, plus 49, which is the square root of 65, which is 8.1. Notice that these two match. So we do have opposite sides are congruent. I noticed that AB is congruent to CD and BC is congruent to DA. So the sides are congruent. The opposite sides are congruent. So this is a parallelogram. Here is another choice that we can do here. The second choice is we can always find the slope and to show that the opposite sides are parallel, which means the slope is the same. They have the same slope. So let's graph this. I got some negative signs here. So let's see here. Let's put this, try to put my X and Y in the middle. So let's start with A. A is negative 7, 5. So 1, 2, 3, 4, 5, 6, 7. Positive 5. 1, 2, 3, 4, 5. So this is A. B is negative 2. Negative 4. 1, 2, 3, 4. This is B. C is 8. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is C. D is 3, 1. Okay, and this is D. So let me connect all of my sides like so. This looks like a parallelogram, but we have to prove it. That means we have to show that the slopes are like, what is the general? This is a quadrilateral for sure. Now we're going to use the slope formula to find parallel lines. Remember, the slope is the change of y's over the change of x's. AB. AB is negative 7, 5, and B is negative 2, 4. Remember, y's on top. So 5 minus negative 4 over negative 7 minus negative 2. I'm going to change these doubles to pluses. So this is 9. Negative 7 plus 2 is negative 5, which is negative 9/5. BC. BC is y's are what? Negative 4 minus negative 8. X is on the bottom. Negative 2 minus 8. This turns into a positive. This becomes negative 4 plus 8 is positive 4. Negative 2 minus 8 becomes negative 10, which simplifies because they both are multiples of 2. I can divide 2 from the top and the bottom. So this becomes negative 2/5. CD, I got negative 8 on top, negative 8 minus 1. On the bottom, my x's are 8 minus 3. So this gives me negative 9 on top, and 5, negative 9/5. DA gives me the y's on top, so 1 minus 5 on top. Your y's, your x's are 3 minus negative 7 on the bottom. This gives me what? Negative 4. 3, this changes to a plus. 3 plus 7 is a 10. Simplify that, gives me negative 2/5. Divide both sides, the top numerator and denominator by 2. And I notice some matching slopes here, right? I notice that these opposites, AB and CD, these slopes are the same, and these slopes are the same. So here, what can I determine? I know that AB has to be parallel to CD, and also BC is parallel to DA, and those are opposites. The opposite sides are parallel, and since the opposite sides are parallel, that means we're dealing with a parallelogram. Last choice here, we can use the midpoint formula to show that the diagonals bisect each other. So let's first graph this. I got some negatives, I got some positives, so let me try to put my XY lines here. This is going to be my X origin, this is going to be my Y. A is negative 3, negative 3, 0, so this is A. B is negative 1, 5, 1, 2, 3, 4, 5, so this is B. C is 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. C. D is 3, negative 1, so this is D. Let me connect this. We are dealing with the diagonals, so the diagonals of the parallelogram are the ones in the middle. So we care about these right here. So what general shape? Once again, we have a quadrilateral. Identify two diagonals of this quadrilateral. Well, those are BD and AC. If they have the same midpoint, that means they must bisect each other. So that's how we're going to find here. So the midpoint, let's do diagonal BD using the midpoint formula. BD is negative 1 plus 3. Remember, add our x's, divide by 2. Add our y's, divide by 2. So 5 minus plus negative 1 divided by 2. This gives me 2 over 2, 4 over 2, which is 1 comma 2. Same thing here. Let's do AC, which is negative 3 plus 3 divided by 2. Wait, AC, oops, wrong coordinates. C is 5. The y's are 0 plus 4 divided by 2. This gives me 2 divided by 2 and 4 divided by 2, which is 1 comma 2. They have the exact same midpoints. That means they must bisect each other. Plot your midpoints of your, but you know they are the same. The diagonals must bisect. And then we have a parallelogram.